Syllabus, you're going to be required to differentiate cos x and sin x from first principles. So you're going to have your first principles formula on the formula booklet. You know that you're going to need f of x, which is cos x, and f of x plus h, which is cos bracket x plus h. Using your addition formulae, that as again is on your formula booklet, you can rewrite cos of x plus h. So that's going to be cos x cos h minus sin x sin h. So I'm going to substitute that into my differentiation from first principles formula. I then expand that bracket of cos x plus h, as we've done earlier, and then I am going to consider h tending to 0. Now h is an angle. So when it tends to 0, so h is a small angle. You have your small angle approximations. The sine of a small angle measured in radians is approximately equal to that angle. So the sine of h is approximately equal to h. And the cos of that small angle is approximately equal to 1 minus a half h squared. So you then substitute those back in to the formula that you've got. You're then going to multiply out that bracket by cos x. You can see that when I've done it, I've forgotten to multiply that a half h squared by cos x. So I've gone back and had to do it. So you multiply out that bracket. You notice that your cos x's will cancel. So you are left with half h squared. Sorry, minus a half h squared minus a h sine x all over h. Divide all through by h, because obviously you've got a denominator of h. It's going to leave you with half h minus sine x. You know your limit as h tends to 0, so that half h will disappear. So you have proved by first principles that the derivative of cos x is minus sine x.